Welcome to DAT 215. My name is Joseph Idzorik. I lead product for Amazon DocumentDB with MongoDB compatibility. It is my absolute pleasure today to introduce you to Sergey Padlizov, Director of Engineering for Shopping Experiences at Zulily. Sergey is going to talk about how Zulily drives discovery-based shopping with Amazon DocumentDB and Amazon Kinesis data streams. I'm excited about this talk for two reasons. First, I love seeing customers like Zulily being successful with Amazon DocumentDB. Second, Zulily does discovery-based shopping at scale. In the world of e-commerce, discovery-based shopping is a complicated challenge that requires both really flexible technologies in databases and also really creative thinking from engineers. You will also notice in this talk that Zulily uses multiple purpose-built databases like Amazon DocumentDB, Amazon Elasticache for Redis, a search engine, and all of this to deliver a differentiated e-commerce experience. Each of these databases enables Zulily to deliver a unique set of capabilities so they don't have to compromise on functionality, performance, or scale by trying to run all those workloads into a single database. So without further ado, let me please welcome Sergey and thank you for joining us today.
Have you found yourself going to some e-commerce websites more often than others, where you just keep coming back because they give you a warm and fuzzy feeling? I'm Sergey Padlizov, Director of Engineering in Shopping Experience at Zulily. In this presentation, I'm going to show you how to build a fun and engaging search experience. And I'm going to let you in on a secret, how you can do it faster than your competitors. Let's quickly cover the agenda first. I'm going to say a few words about Zulily and introduce the company to you. And then we'll dive right into defining a great, fun, and engaging search experience. We'll cover alternative solutions. We'll talk about technical architecture and dive deep into it. And we'll close off by covering the technical impact and the customer impact of this feature. So without further ado, let's get started. Zulily was founded in 2010 on a novel value proposition. Amazing deals on unique products for moms, kids, and babies. Today, we've scaled this model. We launch thousands of products every day, and they only remain in our site and in our apps for up to 72 hours. Our customers can find just about anything on Zulily: clothing, shoes, pet stuff, home decor, toys, you name it, anything you want. And please note I said want and not need. Zulily is different in a sense that our customers come to us for inspiration. Our customers are moms, aunts, caregivers, people who always have a perfect present, people who always decorate their house during the holidays, and always have a thing or two to give away during a code drive. It's for these customers and to support our business model, our engineering team built a high-scale e-commerce platform that provides our customers inspiration as they browse. Now, a great search is an important part of this experience. In fact, it's so important that 2/3 of our customers use this feature. It's the second most popular feature on the site. Just think about that. So the team wanted to define what a great search experience is all about. And we came up with 4 pillars. Pillar number 1, suggestive. We want to share with our customers things that other customers are looking for. What's trending currently in our app or on the site. And we want to bring all of that inspiration to other customers. Pillar number 2 is relevancy. In the context of Zulily, and please remember, we have products on the site and in the apps for up to 72 hours. Relevancy means that when we suggest something to our customer, we better have it in stock. We haven't run out of this product. The third pillar is diversity. Zulily carries national brands, for example, Crayola, as well as some well-known boutique brands. Milk Barn would be an example. And we want to ensure that when we give suggestions to our customers, we cover both national and boutique brands. Finally, pillar number 4 is personalization. In today's e-commerce world, personalization, of course, means that we want to display content to our customers that's relevant to them as individuals. So now that we've established what a fun and engaging suggestive search experience is, let's look at what Zulily built. But before we look at the new feature, I want to show you what the old search experience was. And you can see it on your screen right now. As you can tell, there is actually not a whole going on the screen. We have some trending searches, and that's about it. It doesn't provide inspiration. And as a company that provides inspiration, that's not good. So the UX team decided to change all of that. And they came up with an amazing new look and feel for the search landing page. And you can see it on your screen now. So it's visually rich, it's engaging, it's using graphics. It doesn't just talk about trending searches. It covers things like search keywords, but also brands and categories. Equally important, what you cannot see on the screen from these wireframes, is something that happens on the background. And that is what I mentioned to you when we talked about the 4 pillars of fun and engaging search. It's the relevancy aspect. So on the background, this feature actually checks for inventory in our fulfillment centers. And it only shows suggestions to customers when we have inventory on hand and we can fulfill those orders. Okay, so now we're getting into the engineering part. Just like on the previous slide, before I dive into the new architecture, I want to start by showing you what we used to have in place. And so, if you look at the screen, it's basically customers using our mobile apps or the site, and the apps interact with Elasticsearch, getting the search results, as well as trending search keywords from an Elasticsearch cluster via REST API. Okay? So then the question is, how do we build this new suggestive search experience? At Zulily, the engineering team lives by the following principle: design for tomorrow, build for today. So what does it mean? It means that when we design a new feature, we want to ensure that it is extensible and scalable, that we can add on to it in the future. The feature can take more traffic, and we don't have to change our entire system to make that happen. Okay? At the same time, when we build this feature, we want to ship it as quickly as possible, where in e-commerce and also this year has been really tough with the pandemic going on. So we wanted to really get this out as quickly as we could so we could serve our customers better. Following the principle, design for tomorrow, build for today, Zulily, the engineering team, came up with the following approach. We decided to implement the suggestive search feature as a microservice. It takes the data, the events from our clickstream analytics as input, and the output of the service are trending search keywords, brands, and categories, all validated against the available inventory. And because we build this feature as a microservice, it's well decoupled from the rest of the system. Okay? So this is the high-level architecture. Now, let's move on to the next slide. Before we actually dive deep into the architecture, I want to kind of talk about what the service does at a high level. The first step is it needs to extract search keywords from clickstream. Now let's define what clickstream is. When our customers use the apps and the site, they take actions. They visit, they view pages, they click on buttons, they scroll. All of that is getting recorded. And all of that is funneled into a data stream implemented on top of Kinesis, AWS Kinesis data stream. And all of those actions live in that stream. However, in our case, we're not interested in all of those events. We're only interested in the search events. And so the first step that the service, KTOP service, needs to do, it needs to filter out those search events from our clickstream. Step number 2. When a customer enters a search keyword, Apple as an example, they may be thinking Apple computer, Apple phone, electronics, but they only type Apple. So it's our job to translate that search keyword to related brands and categories so that we can make our search suggestions richer. And so this is the second step in this KTOP service, where we do a lookup and we bring related brands and categories for every search keyword that we find in our clickstream. Step number 3, we have to check the available inventory. If you remember, that's one of the 4 pillars, the relevancy pillar of our great, fun, and engaging search experience. So we do that. And then finally, step number 4, we have to save the results in a fast data store where they can be accessed by our customers in the apps and on the site. So 4 steps. Okay, in every system design, you face alternatives. You have these forkroads in the road that you have to choose between A and B. And in this particular case, on this project, the team faced 3 major choices. Number 1, how do we extract search events from our clickstream data? We considered a couple of alternatives here. Number 1, we could have actually gotten it from our data warehouse, implemented in Google's BigQuery. The second alternative was to get it directly from the source, directly from our clickstream data, implemented in Kinesis. The advantage of the first approach, going to our data warehouse, was that those search events were already filtered there. We had a table where we could just run a select against and get them. However, that table is separated from the source. There are several hoops that the data needs to go through before it lands there. Additionally, we're also concerned about using a data warehouse to power a more dynamic experience. So we looked at Kinesis data stream, Kinesis data analytics, as our tool of choice here, because we knew that we could easily filter our search events from this huge data set, hundreds of millions of user actions, page views, etc. So we decided to go with Kinesis data analytics on top of the Kinesis data stream. Alternative number 2, the forkroad number 2, was whether we go serverless or server. And in AWS, for serverless, we have Lambdas, among other things. If we want with a server-based implementation, we could use EKS, ECS, there are a variety of choices. In this case, we didn't really see any advantage of using servers. We felt like Lambda was completely adequate to meet our needs, and we didn't have to worry about the infrastructure. So we went with Lambda. The forkroad number 3 was whether we go with MongoDB or DocumentDB. Zulily, the engineering team here, uses Mongo for a number of use cases. It's a technology that we're well familiar with, we have a lot of experience, and so we felt comfortable making that choice. However, we also looked at DocumentDB, a managed service in AWS. And DocumentDB provides basically all of the functionality, at least the functionality that we needed, for the feature that we were building, and we would not have to worry about the infrastructure. I vividly remember a conversation I was having with one of the engineers on the team. And I said, look, Matt, do you want to be a MongoDB expert or do you want to be a search expert? He said he wants to be a search expert. And that settled the debate. We chose DocumentDB as our data store. Okay, so now we're on the slide that's the meat of this presentation. This is the component diagram, and I'm going to walk you step by step through it so you can learn how we put the service together. We're starting from clickstream, implemented in AWS Kinesis data stream. Again, our customers interact with the apps, with the site, and all of those actions are recorded and sent to the Kinesis data stream. On top of this Kinesis stream, we implemented a Kinesis data analytics filter. This is a really cool technology because basically it allows you to write a SQL statement, or what looks like a SQL statement, against your live data stream. It's incredible. Literally, you write the SQL statement, a few lines, you specify the destination for your data, and you're done. There is no service to worry about. It just starts working. When you set up Kinesis data analytics, you have to specify the destination for your data. In this case, it looks at all of the events in the clickstream. It filters out only the search events, and it sends them to another Kinesis data stream. This is actually a common pattern. When you build queue-based systems, you often will be chaining up your data streams. It could be Kinesis, it could be Kafka, it could be anything, and injecting the business logic between those streams. And this is exactly what we're doing here. Taking all of the clickstream events, applying a filter, and capturing the results in another Kinesis stream. Okay, so now we've got our search events. What's next? Next, we have to look up brands and categories for the search keywords that the customer entered. And so we chose to use Lambda here to perform this operation. On the diagram, it's illustrated as event transformer. Okay? And so this Lambda function gets triggered when new events appear in the Kinesis data stream. That integration is really simple, and actually that was another benefit for us choosing Lambda here, is because literally to get Lambda triggered by a Kinesis data stream, you don't need to write any code. I mean, unless you do infrastructure as code. So we've got our Lambda function. It gets triggered when new events appear in the search events data stream. It performs a lookup of related brands and categories, and it saves the results in DocumentDB, enriched events data store. All right, so we've got our top search keywords, top brands, and top categories. How do we get them to our customers? Well, we still have to do the inventory check, remember? And we've got another Lambda function. So this Lambda function here runs on top of DocumentDB. And if you think about it, how Lambda can get triggered or how we can run it on schedule is a really cool feature. It's very useful. We can use all these serverless compute with different technologies, and they all work together nicely. In this case, Lambda runs a query against DocumentDB, just like it would run a query against MongoDB. It grabs all of the top search keywords, brands, and categories for the last X hours, and then it performs the inventory check. It needs to ensure, by making a call to an API, it needs to ensure that we have those products in stock. And when we make a suggestion to a customer, we can fulfill our obligation, we can fulfill her order. This is the second Lambda function. After we perform the inventory check, the Lambda function saves the data in a fast data store. In this case, it's Elastic Cache for Redis. And this data is available for our customers through the Search API. And this is the architecture end-to-end. Just to quickly recap, we're starting with all of the events in the Kinesis stream. We apply a filter using Kinesis data analytics, identify our search queries, look up related brands and categories for those search queries, save the results in DocumentDB, and then we have another Lambda function running on top of DocumentDB every X minutes that brings up all of those saved top search keywords, brands, and categories and performs an inventory check and then saves the results into Elasticache. All right, so let's talk about the advantages of the approach. Like, why is this cool? We went from the UX design to production in just 10 weeks. Just think about that, 10 weeks. And this was in the middle of a pandemic when we knew that we wanted to get this out as quickly as possible so we could serve our customers better. Okay? So very quick implementation here. Why was it quick? To a large degree, because we used available managed services and we did not have to worry about infrastructure. The team was focused on the business logic, not infrastructure setup. And this was key to how fast we could implement this feature. We also followed the design principle that I mentioned. We designed for tomorrow, so we made smart choices about the scalability, the extensibility. We decoupled the service from the rest of the system. And yet, we built for today. We were able to deliver it fast to our customers. Now, of course, if we build something, but customers don't appreciate it, they don't like it, well, the impact is not that great. So, how did customers react to this service? Customers actually did like it quite a bit. In fact, 75% of our customers use search suggestions that we built for them. Ironically, it has a side effect. Fewer customers perform raw searches because they feel the inspiration that our suggestive search gives them. And this is, again, what Zulily is about. We're different. We want to give people inspiration as they interact with our store. Also, as an, of course, important metric, we're seeing higher customer retention after we implemented this feature. So all in all, from the customer perspective, I would say it was successful. None of that, just none of that, would be possible without the team who built this feature. And I want to give them kudos here. Thank you so much. Nate, Suraj, Ram, Divyesh, and Wendy. You guys were behind this feature that created this new and fun and engaging experience for our customers. Thank you very much. So let's quickly recap what we've learned here today. I shared with you a few facts about Zulily, and then we defined what a fun and engaging search experience is all about. We looked at alternative solutions that the team considered when building this feature. We defined and walked through the technical architecture. And finally, we closed off with the technical impact and customer impact. Before I say goodbye today, I want to share with you a quote from one of the engineers in the team, Wendy. She said, as Zulily developers, we come up with ideas and try different technologies to get the job done. And the reason she said that is because it exemplifies the innovation, the engineering culture, the innovative spirit of the engineering team at Zulily. We face challenges, we have faced problems that we need to solve, and we have the autonomy and the power to choose the right technologies for the job, to choose the best technologies for the job, do the design well, and deliver features quickly. So, in this presentation, I've only touched the surface of several AWS technologies. Specifically in reference to DocumentDB, I encourage you to take to watch some additional sessions to learn more about that and learn how you can take advantage of that as well. I want to thank you very much for your time today. Thank you for watching. I'm Sergey Podlazov, Director of Engineering and Shopping Experience at Zulily. If you have any questions, you can contact me at spodlazov@zulily.com. Also, we're hiring, and so if you want to join a dynamic team that builds great solutions just like the one I showed you, please visit our career website at zulily.com/careers, and maybe we have an opportunity for you. Again, thank you very much, and please complete the session survey. Goodbye.